Hi, fourth graders. This is Mrs. Nagy, and today we're going to complete our lesson 90 lesson with doing all of the problems from 1 through 30. So here we go. Number 1 says, what is the total number of days in the first 3 months of a leap year? So think about the first 3 months. We have January, normally has 31 days. You guys know that knuckle trick, a lot of you. February has 28 days, except in a leap year, it has 29 days. And March always has 31 days. Okay, so adding all of these together, let me get rid of that and we'll just put an addition sign. We're going to say 9, 10, 11 here. 3 plus 3 is 6, plus 3 more is 9. So we have 91 days. The total number of days in the first 3 months of any leap year. There you go. And we're going to go straight through instead of doing star problems and then non-star problems on your own. Today we're just going to do the 30 problems together, okay? Which is going to be very different, I know. Okay, number 2. Again, this is lesson 90, 1 through 30. It's still the classifying quadrilaterals lesson. But since the lesson part was so long, I thought it would be best to do it this way today. So number 2 says 32 desks were arranged as equally as possible in 6 rows. How many rows had exactly 5 desks? And how many rows had 6 desks? Okay, so here we have, sometimes we do this, right? We put how many total, 32 desks, okay, and then it said they were arranged into 6 rows. So let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, okay, and how many rows had 5 desks? So we are doing a problem that is 32 divided by 6 as evenly as possible, and of course we will have a remainder. So let's see, 5 times 6 is 30. 32 minus 30 is 2, and we have 5 remainder 2. Okay, so we have the 6 rows, and we see that there are the 5 of these 6 is going to have exactly the same amount, and then there will be 2 left over. So let's see. So if we say 5 and 5 and 5 and 5 and 5 and 5, right? That would make 30, but we have 32. So this tells us that we have 4 rows that are going to be okay with the 5. Okay, but since there are 2 extra, we'll have to put 1 more here and say 1 more there in that row. And so that answers that in A, how many had exactly 5 desks? Well, 4 rows had exactly 5 desks. But then we had to squeeze in 1 more desk into each of the 2 more rows. So B says how many rows had 6 desks? 2 rows have 6 desks because there's a couple of extra kids. All right, So pause that if you haven't written that down just yet. Let me make sure you can see that okay. And I'm going to erase and continue on. Number 3 says if y equals 3x plus 6, then what is y when x is 4, 5, and 6? Okay, I'm hoping you remember this type of problem. For number 3, I'm going to say, go ahead and write it. Maybe I'll switch to another pen. Okay. This one says, if y equals 3x, oops, I wrote 3/6 instead of 3x. You gotta watch that. 3x plus 6, okay, then what is y? Well, we're still solving for y, but we're going to find out what x is in all these, in the 3 times we're going to do this. So, and I like to draw the ordered pairs over here. Let's see, x and y. So we're told x will be 4, x will be 5, and later x will be 6. Okay, make sure you can see that okay. More important to see the board and hear my voice than it is to see me. Okay, so let's get started. In the first one, we're going to have y. We're going to use when x is 4. Okay, so our problem is y equals 3 times 4 plus 6. Okay, I'll put it in parentheses to make it easy to see. So now let's continue on. Y equals 12 plus 6. So in this case, y is 18. Okay, now let's do, what about when x is 5? Okay, we found out that y was 18 over here. Okay, so if x is 5, let's do this problem again. Y, this is the problem here that we start with each time. Y equals 3 times x, which is now a 5, or 3 times 5 plus the 6. Parentheses always go first. So y equals 15 plus 6, which is, oh, I think I wrote that wrong, 15 plus 6, not 16. And we can see that that is 21. Okay, so let's go ahead and fill this in. So we have a nice little table, a nice little chart. And then we're going to set aside the x is 4, set aside the x is 5. It's like we're done with that. We're done with this. But we need to show it on our paper. So next, x is 6. Okay, when x is 6. So y equals 3 times 6 plus 6. Y equals 3 times 6 now plus 6. Okay, doing parentheses first, we get 18 plus 6. And then y as a final number, 18 plus 6 is 24. So when x is 6, y is 24. All right, and we want to show all of this, but we're done with this part as well. All right, so that is number 3. Now, a lot to it, isn't there? It's a lot for you to write. Number 4. Go ahead and get started if you are ready. There sure is a lot to erase this time. Okay, and you're doing all the problems with me, so you're writing everything I write. Number 4, Carmen separated the 37 math books as equally as possible into 4 stacks. Okay, so think about that. There's 37 math books. Okay, and she's separating it into 4 stacks as equally as possible. So 37 divided by 4. Okay, and how many times does 4 go into 3? 4 doesn't go into 3 at all. So we think, well, how many times does 4 go into 37? Okay, let's see. So let's think about some of our multiplication facts. I'm thinking, what about 4 times 7? Could we use that? That's 28. What about 4 times 8? Well, that's 32, right? What about 4 times 9? That's 36. This one looks like it'll work. So 4 times 9 is 36. And we have a remainder of 1. And the question was, how many stacks had exactly 9 books? Well, let's see. Let me read that again. Let me look at it again. How many stacks had exactly 9 books? There's 4 stacks all together, right? 1, 2, 3, 4. So we divided that 37 into 4, and we know that these 3 will each have 9, 9, 9, 9, but then there's one more, one extra. There's a remainder of 1. So that last stack will get 1 extra book, so 10 books. So A, how many stacks had exactly 9 books? A, the answer is 3 stacks had 9 books. Okay. And then B, how many stacks had 10 books? 1 stack had 10 books. Okay. And that will be your answer for number 4. A is 3 stacks and B is 1 stack. All right, so now we'll go on to number 5. Let's see if a little bit more light helps us or causes too much of a glare. Okay. All right. Now we have question number 5. Number 5 says, write true or false for parts A through E. All rectangles have 4 right angles. That is true. All rectangles have 4 right angles. B, some squares are rectangles. That's false, not true. Some rectangles are squares, but it's not true the other way around. All trapezoids are rhombuses. All trapezoids are rhombuses. Well, that brings us back to, do we remember what a trapezoid is? Look back on page 594. A trapezoid is a quadrilateral, that's a 4-sided figure with exactly 1 pair of parallel sides, okay? Look at the trapezoid on page 594 at the top, E. Okay, so it said all trapezoids are rhombuses. Now a rhombus is a special type of parallelogram whose sides are equal in length. So take a look at the rhombus, which is B and D above, and think about that. A rhombus, all sides are equal. Well, a trapezoid, can only have 1 pair of parallel sides. So Let's see. So the answer to C is false. Okay, let's think about D for a second. All rectangles are parallelograms. Okay, think about any rectangle. And you should think, yes, this is true. All rectangles are also parallelograms. And then E, it says some parallelograms have no right angles. Okay, so some parallelograms, look back at a parallelogram, maybe on page 594. Can you find maybe letter A and B, the pictures at the top of page 594, the little shapes? They're both called parallelograms, and yet none of them have a right angle. So figure something like this. Okay, you have an obtuse angle, and you have, so obtuse, you have acute. They're parallelograms because there's two pairs of parallel lines. This is parallel to this, and this is parallel to this. But this has no right angles. So the answer is true. Some parallelograms have no right angles. All right, let's move on. Number 6 says, what decimal number names the shaded part of the large square at the right? So what decimal number names the shaded part of the large square at the right? So for 6A, we want, and you need to be following along in your book, okay, not just following along on my board. So we're on page 597. What decimal number names the shaded part? Well, first of all, we need to know how many boxes there are. If you think about, I know that you need a decimal number. That's true, so I'll put the decimal, but think that there's 100 boxes, 10 across the top, 10 across the side. That makes 100. And how many are shaded blue? 5 of them are shaded blue. Okay, so that's the easiest way to get started. Now it says A says, what decimal number names this? Well, 5/100ths is written like 0 and 0/10 and 5/100ths. Okay, so that's A. Now B says, what decimal number names the part that is not shaded? Okay, this was your answer, but we figured it out by writing the 5/100. So the not shaded part, we still know that we have 100 of them. 95 are not shaded. So what's not shaded in a decimal form? 0 and 95/100ths with the tongue sticking out. Okay, now number 7. Try to do number 7 on your own. Get started. Number 7 says, near closing time, 31 children and adults are waiting in line to board a ride at an amusement park. Can you picture that? Not right now, right? Every amusement park in our country, probably the whole world, is closed down right now because of the coronavirus. So it says again, 31 children and adults. So altogether, there's 31 children and adults. It says 8 people board the ride at one time. Okay, think about those words, one time. How many people will be on the last ride of the day? Okay, so 31 altogether. 31, we'll just say people for the children and adults. We know it's about closing time, but that doesn't really matter as much. We just need to know that there's 31 altogether and 8 at a time. 8 at a time. Okay, so This is a form of an equal groups problem. We would say 8 if you were to start it with a number sentence. So this is just what we know. So just think. This is what I need to think about. But then I should say 8, maybe say 8 people ride at a time. Because now I'm going to go ahead and write the sentences that we normally write. So 8 people at a time. We know there's 31 people, right? We put the total in the answer. And 8 people ride it at a time. And how many people will be on the last ride? Okay, so let's see. We can say, well, how many, does it work to say how many times? 8 people ride at a time times a certain number of times is 31 people. So let's see, if I say 31 divided by 8 and figure out that math, then we can move forward to and think about the third, let's see, the 3, oh, I'm getting ahead of myself. 8 into 31, hope you can see that okay. 8 into 31, let's see, 8 times what gives us 31, or the closest thing to it? Well, 8 times 2 is 16, right? 8 times 4 is 32, so why don't we go with 3? 3 times 8 is 24, is as close as we're going to get without going over. So we write that number underneath there, and then we do the subtraction. 1 minus 4 you can't do. Cross out the 3, put a 2, put a 1 by the other one. You see that okay? I hope you can. Let me move this even closer to here. Okay. All right. Again, it's not less important that you see me. 11 minus 4. Let's see, what is that? 7. 2 minus 2 is 0. So we have 3 remainder 7. Okay. So we get this number. The 3 represents the total number of the times that they're on a ride. So 3 plus 7, 3 remainder 7 is what we get. So how many people will be on the last ride of the day? So let's see, there will be 3 rides, 3 times that the roller coaster will go. So 3 rides. 8 people can be on it at a time, and so the last ride will have 7 on the last ride. Okay, so that means that I think we figured that one out. Okay, let's go on to number 8. Number 8, let's see, it says round 3,874 to the nearest 1,000. To the nearest 1,000. Okay, so we need to think about, okay, we're rounding to the thousands place. So we're interested in that 3,874. We're interested in this 3. We're rounding to this place. We're looking to the right of that and finding that this 8 is going to bump this up to 4,000. And that's our answer. Okay, I'm just going to keep going. Number 9. Alicia opened a liter of milk and poured half of it into a pitcher. about how many milliliters of milk did she pour into the pitcher? Okay, so let's just draw a picture for a second. Once again, it would be good to have Corbin here or some of our other artists. So she's opening this liter of milk and she's pouring half of it. Okay, so she's going to basically cut it into two, right? So how many milliliters, milli means 1,000, did she pour into the pitcher? So 1 liter is the same as 1,000 milliliters, okay? So if she's pouring half of that, we are going to say that she is pouring about 500 milliliters is poured. Okay, and there's our answer to number 9. Number 10 says the sun was up when Mark started working. That should be our clue that it is probably morning or daytime. Let's see what else it says. It was dark when he stopped working later in the day. How much time had gone by? So for number 10, we start off with, it looks like the start time is 11:30. And that would be a.m. because it was 11:30 and daylight, that's a.m. And then finally, we are ending this at, it looks like it's past 8, but not to 9 yet, 8:40. Okay, so if we were counting from 11:30 to 8:30, that would be easy. And then we'll just add the 10 minutes, plus 10 minutes. So let's count. This is PM, by the way, because it's dark. So 11:30. Let's just count on our fingers. 12:30, 1:30, 2:30, 3:30, 4:30, 5:30, 6:30, 7:30, 8:30. If we were just going to 8:30, we have 9 hours. My little pinky is not raised yet, right? 9 hours was the number of hours plus 10 more minutes. And that's it. 9 hours, 10 minutes is how much time had gone by. All right, I'll need a second to erase while you guys continue on with number 11. Okay. So number 11 says, for 5 days, Pilar recorded the high temperature. The temperatures were 79 degrees Fahrenheit. I'll just read the numbers, 79, 82, 84, 81, and 74. What was the median temperature for those 5 days? So let's write them down in order. Normally I write all the numbers down and then I cross them out. This time I think I can pay attention well enough to say we have 74. The next one, not in order, but in order of temperature, 79. I see 81, 82, and I see 84 degrees Fahrenheit. Okay, so the median means middle. So why don't I just cross out the two on either end, the next two, and circle the middle one, which is our median temperature for those 5 days. So it's 81 degrees Fahrenheit, and that's our answer. If you are highlighting, which I want you to do to make it easier to find your answer, this is what you're going to highlight. Okay. Number 12 says Lena drove 368 miles in 8 hours. If she drove the same number of miles per, same number of miles each hour, how far did she drive each hour? So the part we don't know is the each, is the first line. So why don't we get started by saying, we know 368 miles, we know it's 8 hours. How many Miles per hour. The question is miles per hour. Did she drive? Okay, we know how many hours. We read that it was 8 hours. And we know the total number of miles, which is 368 miles. So what we need to know is this here. So what we'll do on number 12 that we are on is we will take somewhere off to the side where it's not going to affect our answer or anything. We'll say 368 divided by the only other number we know in this equal groups problem, which is 8. Okay, so we think, 8 times what brings us to 36? We know that that's 4. If it doesn't come to you instinctively, look at your multiplication chart. Okay, 4 times 8 is 32. 36 minus 32 is 4, right? And now we have this remainder of 4, but we have the opportunity to bring another number down because there happens to be one there. And we also know that 8 times 6 gives us 48, and we're left with 0 at the end. So 46 is the number that goes here. 46 times 8 is 368. So the answer is 46 miles per hour, or 46 miles each hour. How do we explain this? To explain it, we would say I divided 368 miles by 8 hours, but I don't need the explanation part today. All right. So number 13. All right. We're already about 30 minutes into our lesson, and we're almost halfway done. So it's going to be a little bit of a longer video. If you want to take a break soon, you can. I don't think we've been going that long, but we will do every single problem together. So I'm going to keep going, and I want you to finish all 30 problems today. Math should take you about an hour a day, and that gives us about a half an hour left to work on, okay? So number 13 is 496,325 plus 3,000, watch that you put it in the right place, 680. Just adding these together, 5 plus 0 is 5, 2 plus 8 is 10. See what I did? 6 plus 3 is 9, plus 1 is 10, and 6 plus essentially 4 makes 10 again. I'm gonna remember my comma. 9 plus 1 is 10, and above the 4 I put a 1. 1 plus 4 is 5. And all together I have 500,005 as my answer, and this is the part you'll highlight. Okay, I'm going to go ahead and go on with another color, number 14, just to save a little time, is $36 minus $30.78. Okay, a problem all the way back from lesson 52, as you can see. Okay, let me go ahead and put down my decimal point first of all. I'll have to borrow from the 6, put a 5. Okay, now that I borrowed from the six, a dollar, I need to break it up. This will become a 9 to represent 90 cents, and then the rest of the 10 cents will go over here. 10 minus 8 is 2. 9 minus 7 is also 2. 5 minus 0 is 5. 3 minus 3 is 0. I don't need that 0. And I have $5.22. Okay. Now, I would like you to very carefully write down number 15. Put them in the right order, check it, and then pause the video for just a moment. And I'm not going to do this one with you. I'm going to give you the answer. So pause. Now come back. The answer is $17.65. We're not going to take the time to add. That's like a lesson 11, started in lesson 11. So we're not going to do that one together, but make sure you get $17.65 and do it maybe over and over if you have to until you get that right amount. Number 16 is 26 times 24. Okay, so multiplying a 2-digit number by another 2-digit number. We start, so this is just like saying 26 times 4 plus 26 times 20. So what is our product? Well, we are going to do partial products first. 4 times 6 is 24. 4 times 2 is 8, plus 2 is 10. All right, so that completed this. I might cross it out just to get it out of the way. Now I'm going to add the 0, my placeholder for the 20 that I'm going to multiply by, okay? And say 2 times 6 is 12. So 2 down here, put the 1 above the tens place. 2 times 2 is 4, plus 1 is 5, okay? There's my partial product of 26 times 4. There's my other partial product of 26 times 20. And so we add all of this up. 4 plus 0 is 4. 0 plus 2 is 2. 1 plus 5 is 6. And for number 16, I'm checking, and the answer is right, 624. And I'll just go on to number 17 over here. Okay, 25 times 25. Oh, that's a fun problem. Okay, this is the same as 25 times 5 plus 25 times 20. We could do it separately, but we'll do it all in one place to make it quick and easy. 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. I'm going to just kind of cross that out so I don't accidentally add it again. Put down the 0. Now we move on to the 20 really. So there's my 0, and it's 2 times 5 is 10. Put down the 0, put the 1 up here for 10. 2 times 2 is 4, plus the 1 that we carried is 5. So all together we have 5, 2, and 6. So our answer is 625. Okay, for number 17. Go on to number 18 once you have this down. Okay. Number 18 says 8m, or 8 times m, equals $16.40. So this is just like saying 8 times m equals $16.40. Okay, well, I don't know what m is, but I know how to write this fact another way. I could write it $16.40 divided by 8 equals m. That makes a little bit more sense, doesn't it? So I'm kind of like simplifying. So I'm going to work off to the side for a second and say $16.40 divided by 8. Since there's a dollar sign, I'm going to go ahead and put that up there first. 8 into 0 we can't do. 8 into 16 is 2. So we put the 2 over the 6, the last part we're dividing into. 2 times 8 is 16. We subtract. We bring down the next number. It's a 4. And we find 8 times, the question is 4 divided by 8. 4 divided by 8. Or 8 times what makes 4? Well, 8 times nothing makes nothing. There is no number. So we'll just say, okay, we're going to have to use a 0. 0 times 8 is 0. And we're going to bring down that 4 as the remainder. But look, there is a 0 here. We can bring down. 8 times 5 is 40. And we subtract, and we have nothing left. So the answer is, looks like 205, but is it? No. Make sure you bring the decimal point up. That decimal point tells us that it's $2.05. And does it make sense that $2 and a few cents times 8 is $16 and something? I hope so. So M, we solve for M. 8 times what is 1640? 8 times $2.05 is $16.40. All right, so that's number 18. Let's see what's next. Number 19 says 60 times 300. 60 times 300. I always like to put the bigger number at the top. But in any case, I'm seeing a bunch of multiples of 10. I see 3 times 6 is 18, and add 1, 2, 3 zeros. Number 19's answer is 18,000. Okay, moving right along. Let's switch to another color. Number 20. Number 20 says $6.56 times 7. So $6.56 times 7. I love this stuff. I hope you're enjoying it. 7 times 6. Well, 7 times 7 is 49. 7 times 6, 42. So the answer is 42. 7 times 5 is 35 plus 4 is 39. I know 7 times 6 is 42 plus 3 is 45. And there you go. Put your decimal point and your dollar sign, and we should have $45.92, which would be true, is true, if I had written the right numbers. The correct number was $8.56. Whoops. Sorry about that. Let's see. Let's try that again. You see how important it is to look at your numbers again instead of just assuming that you had it right? 6 times 7 is still 42. 7 times 5 is 35 plus 9. 35 plus 9. Let's see. No. 35 plus 4 is 39. 7 times 8 is, what is that? 56. And 3 more is 59. So our correct answer is $59.92. I think I'm getting a little tired, and my contact lenses are feeling a little fuzzy right now. So I'll try to pay very close attention and make sure we don't waste any time. So number 21, let's see, 845 divided by 7. Let me check again. 845 divided by 7. How many times does 7 go into 8? 1 time. 1 times 7 is 7. We subtract. We bring down that 4. Ooh, 2 times 7 is 14. There we go. Bring down the 5 right under here. How many times does 7 go into 5? Or what times 7 makes 5? There really is nothing. So we're going to just put 0. 0 times 7 is 0. That releases the 5 to be our remainder. 120, remainder 5. Okay, very good. All right. If you're having trouble with any of this, please, at the end of this problem, put a big circle around it if you can't figure out how to do a problem, and then join our Zoom meeting or give me a text message saying that you really need help. If mom or dad are not able to help you, just text me. My phone number is 916-402-1275, and let me know what problems you need help with. And I can certainly try my best to help you. Okay, and we'll set up a Zoom meeting every Wednesday from 11 to 12 to answer any questions you're just really stuck on, or any concepts. If you need help with long division, with, well, whatever it is, just let me know. With time, with multiplication of big numbers, whatever it is, I'm here to help you. Number 22. Let's see, can you see that? Okay, now that's a little bit dim. Let me rewrite that. So number 20, that's a little dim too. Let's see if I could find a really good marker that isn't wet from my board. So number 22 is 1,000 divided by 9. 1,000 divided by 9. 9 times 1 gives me 9. That brings down, then we can bring down the 1. This is fun. What times 9 brings me close to 10? Again, 1 times 9 is 9. And I subtract. Bring down the 0 again. So I'm dealing with the 10 again. 1 times 9 and subtract, and I get a 1, and I have nothing left to bring down, so that means my remainder is 1. What a fun problem. All right. Pause it if you need to look at it more. But I'm going to move on to number 23. Number 23 says 436 sixths, which is the same as 432. 432. Let's get this thing going. Divided by 6. All right. Let's see. Where can I begin? Right away, I'm noticing that 6 times what will bring me closer to 43? Well, that's a 7. 7 times 6 is 42. And we subtract and get 1. Bring down that 2, and we have 12. 12 divided by 6 is 2, just like 2 times 6 is 12. And I subtract, I get 0, which means there's no remainder. The answer is 72. Okay, let me move on over here. Number 24. Number 24 says, draw and shade a circle that shows that 4/4. So cut a circle into 4. That 4/4 is the same as 1 whole. And that's it. And then we go on to number 25. Remember, pause it if you haven't written it down yet. Okay. Number 25. Let's see, what kind of marker can I use that is going to give you a good result seeing it at home? Number 25. Okay. 25 says the wall was 8 feet high and 12 feet wide. How many square feet of wallpaper were needed to cover the wall? Okay, did you guys have wallpaper in your home? I don't have any wallpaper in my home. I have sheetrock painted. I have some rock work on this wall, but I don't have, I really don't have any wallpaper. But some people do, and when you buy it, you have to measure how much you need by measuring the length times the width. So that leads me to think about this wall. The width says that it is 12 feet wide. 12 feet wide. 12 feet. And it said wide, so we're thinking this direction, and 8 feet high, 8 feet high. And then it says how many square feet. So to figure out square feet, we know we do length times width. 12 times 8, 2 times 8 is 16. 8 times 1 is 8 plus 1 is 9. And we have 96 feet squared, or 96 square feet, which means the same thing. Okay, let's see what's next. Number 26 says below are Team 10A's scores on the first 7 games. Refer to these scores to answer parts A through C. So we are going to have to write these down. Okay, let's see, we have, this is number 26, and the numbers are 85, 100. We have a 90. Oh, let's make that a little neater. Let me start again. 85, 100. We have a 90, an 80. We also have 100. And we have another 85. So in letter A, I think I'll switch to another one, another color. Letter A says rearrange the scores so that the scores are in order from lowest to highest. Okay, let's write it lowest to highest. I see 80. Okay. Next, so let me cross that out. 80, I see 85 3 times. 85, 85. I see a third 85. Next I see 90. I see 100. And lastly, I see another 100. So I've got my 200s and I've got my 90. And there they are. Next it says in letter B, is your answer to part A, in your answer to part A, which score is the median, remember that means middle, score in the list? Okay, so that means we're going to say, we're going to go end, both ends. Drop off the first one, drop off the second one, drop off the third one, and guess what we have? 85 is the median, or the middle number when it's in order. That's why they had us arrange it in order. Median, M-E-D-I-A-N, the median score. Okay, but there's still a C, which says in the list of game scores, which score is the mode? And since we know mode means most, which one is used the most? Let's see. Let's go back to these numbers here. I see there was 3 85s and there was 2 100s. So I'm going to say 85 is the mode. Okay. Ooh, my spray bottle is covering the word mode. And let's move on. Okay, got that? See all that work that it took to do number 26? Number 27 asks you, what is a reasonable estimate? Ooh, that sounds like we're going to round something. Okay, what is a reasonable estimate of the number in each group? In each group, we don't know the number in each group. Think about that. Okay, so what's a reasonable estimate of the number in each group? Let's find out what it wants. When 912 objects are separated into 3 groups, okay? Except that we want an estimate. So what number should we use instead of 912 to figure this out? Well, it sounds like 900 would work. So let's do the estimate instead. Estimate. Okay, 3 goes into 9 3 times. 3 times 3 is 9. Don't just leave out all the zeros. You need to use them. Bring down the next 0. That is going to give us 0. 0 times 3 is 0. Do the subtraction. Get rid of all the zeros so that you know how many you need at the top. What times 3 makes 0? Or in other words, 0 divided by 3 is 0. So our estimate is 300. Again, let's read it. What is a reasonable estimate of the number in each group when 912 objects are separated into 3 groups? You could think of it this way. 900 into 3 different groups. Wouldn't that be 300 in each one? Approximately. I hope you see that that works. Okay, number 28. We're almost to the end now, guys. '28 says, according to many health experts, a person should drink 64 ounces of water each day. If Shankidra's glass holds 8 ounces of water, how many glasses of water should she drink in one day? So the part we don't know is the each sentence, right? So how many glasses should she drink glasses in a day? Do we know how many days? No. Oh, it says in one day. So in one day, that's right. So we don't know that. What we know is that she has 8 ounces of water and 64 ounces total. So let me rethink this. 64 ounces. There are, I'm going to start this. There are 8 ounces. Let me think through this. 64 ounces. Her glass holds 8 ounces of water. How many ounces should she drink in one day? So how many, I should probably put ounces instead of glasses. How many ounces drank would make more sense. The number of ounces drank in a day. Okay, so we see now that we have this problem where it's something times 8 is 64. Guys, I think we all know the number that belongs there is 8. So 8 ounces drank. No, it should have been glasses. Let's see. 8 glasses in a day times, yeah, I guess the words don't really work out very well on this one. So let's see, 8. Yeah, let's go back to glasses. Sorry, this one's giving me a little bit of trouble. So 8 glasses in a day times 8 ounces in a glass is going to give us 64 ounces. It doesn't work out as well and as easily as usual, but I think you can, that's why they use smaller numbers, 64, 8, and 8. So ultimately what we need to know is 8 glasses. How many glasses? It's 8. 8 8-ounce glasses per day. Okay. Every once in a while we run into one of these problems that doesn't fit as easily as usual, but knowing the foundational 3-sentence structure that we use usually helps us almost every single time. Not quite always. Sometimes we have to think, just think through the logic of it. Number 29. We have Arthur told his classmates that his age in years is a single-digit odd number greater than 1. So a single-digit odd number greater than 1. I think this is a child. He also told his classmates that his age is not a prime number. How old is Arthur? So if it's not a prime number, it needs to be a single digit composite number. Sounds like a pretty smart kid. So he's probably not a 1 or 2-year-old or anything, right? So let's think about the numbers that it could be. Okay, single digit numbers, they're numbers like 1, 2, 3, 4, 5, 6, 7, 8, and 9. And anything after that, obviously, is going to be a 2-digit number, so it won't work. Okay, so think about what numbers could be possible. So it's a single digit. Okay, we've got that part checked off. And we have to have a composite number. A composite number, remember, is the opposite of a prime number. A composite number is going to be a number that has more than 2 factors, 1 times itself. So obviously it's not going to be 1. Okay. If you think about each of these numbers, let's just factor out right underneath it. 2, it comes from 1 times 2. That's a prime number. 3 comes from 1 times 3. That's another prime number. Okay, so I'm just going to start erasing these to give myself some more room. 4, that comes from 1 times 4 or 2 times 2. Okay, that's a composite number. Do you think, though, that a 4-year-old is talking like this? Could Arthur be 4? Okay, let's think about the number 5 now. 1 times 5, oh, that's a prime number. What about 6? 6 is 1 times 6 and 2 times 3, right? So could it be the 6? Okay. It also said that it is a number greater than 1. That was another reason to get rid of the 1. And that it's not a prime number. So let's see, could it be 7? 1 times 7. That's a prime number. So here's another one that cannot be it. So let me get rid of this. And let me get rid of this. Okay. Let's move on. Let's see. Let's move on to number 8. what makes 8? 1 times 8, 2 times 4, and so on. So that's a possibility. What about 9? 1 times 9? Could it be 1 times 9? 2 times nothing, 3 times 3. Okay, so here is another option. Single digit odd number greater than 1. Okay, now we have to rule out one other thing. Something that we haven't mentioned yet is that it's an odd number. Okay, we've been looking for composite numbers and we've been looking for single digits. Okay, so now we've got all 4 composite numbers. And lastly, it has to be an odd number, which rules out the 4, the 6, and the 8, and leaves us with just a 9. Okay, very good. Lastly, we have number 30. Number 30 says, if y equals 3x minus 1, okay, what is y, we're still looking for y, when x is 2? So we're going to substitute that x is really 2, and then go ahead and write the minus 1. So y equals, do parentheses first, 6 minus 1, which means y equals 5. Okay guys, that's all of our problems, 1 through 30. We did that in 1 hour and 6 minutes. Hopefully you took a break somewhere along the way. And you have no more 1 through 30 homework for today. Check BrenWeb for what else you might have to do in math, but that's it for this. When you do facts and flashcards and things, I want you to keep in mind that it is important that you keep learning your multiplication and your division, okay? You see how much faster things go when I can think of what 6 times 7 is and so on. So that will really help you. Okay, love you guys, and I'll see you at the next lesson, and I'll talk to you later. Bye.